Welcome everybody that is already here. And just a little bit to my background. I started in the year 2000 in a big commercial bank with classical Inman modeling. And I gained the experience how difficult it is to change something. So I really experienced these problems that we as well read in the data mesh book of big data corporations, how difficult it can be to bring in changes in a long existing data warehouse. So when I switched over back in 2006 to a telco company leading the data management team, we tried out more a little bit of Kimball style data modeling, and it was much simpler back then for smaller systems, but we have too many data sources. It wasn't working out. So back in 2012, I came across the point where we tried out Datavault modeling, and we stayed there since then. We started back in 2012 creating a tool which became 2015 the Datavault Builder, which I will present in the second part in a live demonstration. But in the past 2 years, the question came up, how does data mesh and data vault play together? Is it something different? Is it either or? Can it be combined? And this is what I want to show a little bit here, my thoughts about this and how this can interact. And if you have any opinions on that, I'm very happy to discuss this as well at the end. If there are any questions, there's a Q&A section. And thank you, Jean, for highlighting that my microphone was on mute. And we will see as well if there are any questions in between. I would stop again and again and check if there's anything in the Q&A section. So please don't hesitate to ask the questions when you have them. So what was our experience? Why are data warehouse projects failing? There is a perception of high cost. Is it real? Yes, I've been on projects that were very costly, that produce as well a lot of business benefits, but that were suiting only big companies. And the longer data warehouse projects were running, the slower they became if we were using Inman data modeling, because we had to normal form, we needed to model everything first, then implement it. And this was okay like 30 years ago when there were not much changes in our source landscape. But now the source system changes sometimes in an agile fashion. We have some external data systems running maybe in the cloud that are updated constantly. We have external data providers providing us constantly different data. And maybe we're buying some data sources and we need to implement it. And it becomes more and more complicated. So with a classical Inman design, probably we fail a lot of stuff today. And what we have seen as well is that the people in the different business departments feel a little bit alone. They depend on central data teams if there is only one data team, and they need to get prioritized by the data teams because they have so much work. They have a long backlog. They can never work down that they solve everything. So they need to prioritize between different data teams. And this is perceived as a big problem in bigger corporations. So here comes in the central question that I think data mesh is talking about. It's about centralization versus decentralization. And both of these aspects have different benefits and problems. And this is not the first wave of this discussion that we see as well. Back in the past, we had this again. We tried to move stuff into the business departments. We figured out they can't manage it. They don't have any governance, so we need to bring it back and centralize it again. Then we centralized too much, brought it back. So this is not like a black and white decision. This is something that you need to figure out for your company. But the data mesh approach helps you to give you very good ideas, to give you a vision how a decentralized data warehousing or data processing, data reporting can work. So what is the benefit of a decentral data processing? It can scale. It means that instead of having one central team, if you have 5 business departments that need reporting or data analysis, you could have 5 different data teams. If you get a 6th department that needs some data, you instantiate a new department team. And again, every department is happy. Every team is only serving one department, so they know who they are working for. The local department is paying usually for that, so they can pay more if they need more service, stuff like that. And these local teams can have a lot of more business knowledge because they are very near to the business people where they are located. The problem with this is if you're the central IT guy, that you figure out that a central governance is missing, especially if we have topics today in Europe like GDPR, where we need to have some data privacy, where we need to report on who is owning the data, what is done with the data, what is the data lineage. It can be a nightmare if every department has a completely different implementation, if they have completely different tool stacks. And what you shouldn't forget is you need local resources. So let's assume that you have a data team of maybe 7 people and you split it up over 4 departments. And now you have 1 to 2 people in every department. Now it becomes difficult for the local resources to get their things running. So they need to start inventing stuff for themselves. So they start to create very creative. They use the tools they know. They maybe do some low code stuff just with something they downloaded from the internet. Everybody uses something different, and this gets into a maintenance nightmare. So it's not only just a decision to decentralize stuff and everybody will be happy. So you need to have a clear strategy. What happens if you decentralize it? And this is really something that the data mesh concept is talking about. How do you data governance sidecars, how you can share the infrastructure between the teams, what you should distribute, how you could do different APIs that the different teams can communicate and profit if they produce something. So decentralization can have its benefits, but first thing is you should have a plan how to do it. The second thing is you probably need a certain size of your company. And here comes in my personal experience. If I would have a central data team of maybe 7 people, I wouldn't split it up. If I would have a central data team of about maybe 14 people, I would start thinking about if it can make sense to split it up into 2 Scrum teams of 7 people and maybe make them responsible for parts of the data stuff, which could be perfectly fine. But if you have a really small team, 2, 3, 4, 5 people, I wouldn't try to split it up. I would go into automation and make the central data team more productive. And I think still, if you decentralize, you should thinking about making the people more productive. So really the recommendation is read the book by Zhamak Dehghani. There is a lot of good input. See through what fits for your company. But if there are parts that doesn't fit for your company, that's fine as well. There are a lot of other good literature about this kind of data processing. I would still recommend to read Inman, even if it's overcome a little bit. I would still recommend to read Kimball. I would recommend to read Lindstedt. There are many good books about this kind of approaches, how you can manage all of this. So what is the basic idea? The basic idea in this data mesh book, as I understand, is that we don't create small fragments of data, but we create so-called data products. Data products are a little bit self-contained, topic-oriented interfaces where I can receive knowledge about one specific core business concept in my business. Let's assume this could be about products, this could be about customers, this could be about sales. And the idea is that the knowledge how to create such a data product for a specific topic is distributed in a bigger company. Still, we need to provide with this data product a standardized metadata information on what is it about, what is the data quality, how should it be used, how often it is published. We should provide lineage information, where is the data coming from, what is the confidence level, and a lot of this stuff. Still, how you implement this kind of data products would be a local decision. So it could be that there are different data domain teams taking care of different data products, which are using a different technology stack. How far it makes sense or not is something that you need to decide. But still, for us, it can make sense that this is a viable option. So where does now Datavault come into this whole equation? Is data mesh replacing Datavault? The book is published later than Datavault. Is data modeling obsolete at all? And sometimes what some data modelers come and ask, is everything that we did in the past bad? No, it isn't. It's usually evolution of different concepts, and these concepts are usually complementary. So Datavault is a type of modeling. In Datavault 2.0, there's as well described how you can combine it with some different techniques like agile development, how you can manage your master data, and a lot of other stuff. But it's not touching the subject if you have a central data team or a local one. And I think they agree on that there should be some historization of data and stuff like that. So for us, it's more like complementary, that Data Vault and Data Mesh are covering different aspects of data integration, data management, data reporting. And which are these functions? So one of the functions that we need to solve is integrating data from different sources. Even smaller companies today have 4, 5, 6 different data systems, and usually not recognized as such. It could be like they have one CRM, one ERP, but as well they have something like a web shop. They have some Excel sheets that contain crucial data and are responsible for providing data to operational systems. And you have maybe a mailing list, and you want to bring everything together, that you know, like which information you have about which customers. Imagine as well a mailing list contains GDPR relevant information about your clients. If they open their emails, if they visit the web shop, is information about your client that you should bring together to have a complete picture. And still, I go again and again back to Bill Inman to get his description of a subject-oriented, non-volatile, integrated, time-variant collection of data in support of management decision. And the cool thing is, already Bill Inman was thinking about this subject-oriented thing. So this is not something new. But the new thing, the new aspect of Data Mesh is about formalizing how we bring the different subject-oriented topics to different data teams, how collaboration between can work. So it's a good thing to read really all the literature and try to combine how this can work together. So what is still the value of a model? Because this is a little bit where my disagreement comes with the data mesh concept as described in the book is, should we omit creating models? Because in the past, data models were perceived as stopping and slowing down data projects. Because when I started back in the year 2000, it took us about 7 months to create an enterprise-wide data model for the data warehouse, and we wouldn't start like developing anything before the enterprise data model was finished. And I agree with this approach was something wrong, because the business user didn't got any value immediately out of it. But let's take the good stuff out instead of replacing it all. And the data model is giving meaning to things. It expresses relation between things, and it's a mean of communication, how we can show the business users what we will create, and if they get the data, how to understand the data. And this is very, very crucial, especially even if we do decentralized production of data products. We need to understand how they fit together and what the result is, what it will mean. So if we have like a person, what is a person? A person could be a customer, could be an employee. And just by using these simple discussions, putting in definitions, it helps a lot later on to differentiate when we get the result out of our systems and create our reports to understand what the differences are, that we have maybe different treatments for the privacy of these different entities. And this is a good thing. But on the bad side, it can be too abstract. And if manually implemented, it takes a lot of time and it's not directly valued. It means we model at some point, and later on, we still need somebody to implement it. So people were asking, why don't we just implement? And we have something like documentation already just by looking at the code. And one other problem was, in this approach, very often the implementation was not matching 100% the model that was created before. So the model was not very of use because you couldn't rely always that it matches. And this is something that we need to solve. And this is the question is more, how do we solve the bad parts about modeling and not how to replace data models, in our opinion. So here we come in our answer. And yes, honestly, I'm biased. I'm working for a data warehouse automation tool vendor. So this is our solution, but I believe strongly, really from a data modeling perspective, it's the right approach. We need to figure out how we can convert data models automatically into code instead of trying to produce data products just by code. And we need to automate not only conversion of data models into code, we need to automate everything around it. And there we agree on with the data mesh approach, we should automate infrastructure, we should automate data lineage and everything around it. And then we should choose a data modeling technique which is optimal for automation as well. So let's assume that we model something like a person. Our expectation is, and that's what we do with the Datavault Builder, is that the same second we model something, the implementation is happening in real time. So the database table is created. And very important for us is as well that this knowledge from the models is accessible directly in the database. So we attach the metadata that we created in the model directly in the database. And if we check in this object into our Git repository, this metadata is attached to the object in the Git repository. So there is no media break between the different elements. And I think this can reconcile all these different concepts like modeling, data vault, and data mesh into one working solution. And why are we using data vault as a modeling technique? It's designed for agility. And we strongly believe that today, as the data integration thing is a process and not just one project, a one-off that is finished, but it's changing constantly, that the data vault approach is the right modeling technique for this kind of evolution. And it's designed for automation. I can automatically map every object that I model directly deterministically with implementation on the database. And the good thing is it's more normalized than any kind of output. This means that if I'm going into the data vault core parts, like identifying a concept or business object and describing the concept in third normal form, these two functions, including the relations, would be one table. And in the data vault concept, we are splitting it up into smaller bits. So storing the key of a thing will be happening in a hub. Describing the attributes of a thing will be stored in a satellite. And if you relate several concepts together, so like a customer to a product, we have a relation entity, and this will be a link. So we are hyper-normalized. We're more normalized in third normal form. We're more normalized than dimensional. We're more normalized than anything else. This means that on the way out of our data warehouse, we can denormalize it without any issues down to the level that we need as well to data products. And this is exactly the concept that we are preaching, that we say, hey, look, here we have a hyper-normalized core that is automatically created by a data model. And on the way out, if we want to present it as data product, that's fine. But if we have a data scientist that just wants to have a flat table, that's fine as well. And it could be a data product as well. So here we're completely free to represent it as a third normal form output, as dimensional output, or whatever we need. So what does it mean now for our data vault versus data mesh question? We strongly believe it's a plus if you're in a bigger corporation. If you're in a smaller corporation, it could be the data vault with automation is everything for you. But here in bigger corporations, we believe that data vault with automation and the data mesh approach to put the responsibilities in the different teams could be the right approach for you. So let's have a look at, and let's go to more practical examples. So how would data vault in the different data domains work? The first thing is it's about automation and standardization. So if we have a standardized approach, we know exactly how we can manage governance in the different data domains because it's driven by the process. It's driven maybe as well by the tooling as we do it in the Datavault Builder. It allows simple integration into the experience plane. So if we want to bring all the data products from different data domains together, we know we can do that because naming is standardized. We know how access is standardized and everything is well defined. So we just need to do it. We need to find a technology to bring stuff together. I will highlight a little bit later some examples how you can do it, but it will depend as well on your technology stack. And by using automation standardization, it will reduce risk. It will improve or shorten time to insights and everything, and everybody becomes happy and gets constant output. And this allows that the business users support the process, you can continue, and you can evolve this kind of process. So do we recommend that every domain should become a Data Vault domain? I don't think so. Let's have a look at, we have here in this simple example that I will show as well later in the demo, we have customer data, we have product data, and let's assume we have IoT data. And if we get IoT data in real time, just streams coming in with sensor data, it could be that this kind of domain could benefit of just a simple Kafka streaming to some NoSQL technology that is very cheap in storage because it's producing a lot of data, and they create their data product on querying this kind of NoSQL technology. This is perfectly fine, but there still are many domains where we need to integrate data together to give it meaning, that have relations between the different domains. That is crucial to understand it, because the product is really cool to understand, but it would be very cool later on to understand who bought this product and which customers bought which product categories, stuff like that. So here we need to have some more order, some more meaning to it. So our approach here is that, and this is just a proposal that you could use, and I will explain the benefits and drawbacks of it, is that you can use a central data model. And now some people will come that already read about data mesh and say, hey, stop. The central part we want to get rid of. And let's make clear why we want to get rid of the central part. We want to get rid of a central part that is blocking us. So the assumption here is that we have local implementations that are completely free to do whatever they want. They can work in their pace, but this is like a coordination model that people can meet. But still, if something is not added to the central model, people are completely free to already implement it locally and later on just redeliver what they changed to the central model if it's relevant for other domains. And what is relevant? Relevant are edge objects. This means, like, if we have here really the product identified like by the product key, it could be that it's relevant that it can be linked from the customer side or from a product, from a sales side. So this would be something that just the definition that the product exists, not its implementation, could be captured here into the central data model. And I will show you in my live demo that we will capture here some concepts. We will not capture any implementation. We will distribute it to 2 different domains, and then we will do the implementation locally. And by having the central model expressing the relation between these 2 things, we can then send this information to our experience plane, and we can create a report out of the box without any coding, bringing the data from 2 different domains together. So let's have a look at how this looks like. So welcome to the demo part. In this section, we have created 3 different environments. One corresponds to the central team. One is about the customer. It's a data domain installation, and we have a second data domain installation about sales. And the basic idea is that this sales and this customer team should be completely independent. So they have their own instances. They don't see each other's stuff. They're not dependent. They can deploy in their own speeds. They don't get blocked. And you can scale this a lot. You can have as many teams as you want. But still, we want to have some central governance and bring the stuff together later. So the idea is that we have here a central team, and the central team should be set up in a way that it's not blocking any local team. So you're allowed to create your own objects in the different data domains. But here you can agree on parts of the model. And the idea is not that we're creating here an enterprise data model, but let's assume that we want to cover these first 2 topics. So let's add here a customer, the subject area of the customer data domain, and that this customer will have address, it will have type of customer and stuff like that. We leave it here out. We are really talking about the conceptual level of stuff. And here, let's add here as well the order, and this will be part of the sales. And why are we adding this to this basic model is that there will be a relation between the sales data domain and the customer data domain going through the order. So let's add here a relation between them. There will be many orders for one customer. And that's it. We don't go further. That's the level of grain we implement here at the central team. We go in here and we say maybe one order represents, and we define on what we mean by things. So like a customer is somebody that ordered in the past 3 months, something like that. And at this level, we now deploy these changes into the different data domains. So they have access to these basic objects. They can add the implementation and add further. So let's go now and distribute this very simple model to the different data domains. The connect environment. And I connect first to the customer data domain. And it compares now the environments. Now we see in here that there is already stuff that we would delete if we would just override the data model. We don't want to do that. We want to filter for only the stuff that we added here and distribute it. And if I say I like to do that, it means that there are as well REST APIs automating this kind of process. So it doesn't mean that you need to do this here manually. This is just that we visually see what the differences are. So select all filtered, and we deploy now only the addition of these new elements to the different environments. Let's do it and distribute it. And this doesn't need to be at the same pace. It can be at any other point in time. We can distribute it now as well to our sales data domain. They can pull it on a regular basis, like nightly, or if there's something changes with an active CI/CD pipeline. And let's switch now over to our customer domain. And what we see in here that this stuff that we created centrally was deployed. So we don't care about the sales domain. It tells us, yes, there will be later a relation, but we care only about the customer. And now we can start implementing it. And I already connect here in my customer domain a source system that will provide the customer data. We have already staged it. This is all a built-in functionality of the Datavault Builder. I will not go into the details of that. I just showed that we can now connect this kind of person information that we can maybe preview here in, if you have different first names, different last names. We can look at the value distribution, which kind of names we do have in here. And now I will map the data that I staged against this data model. So let's add it here, add a load. Let's take this person information and the business entity is the business key, and automatically create a satellite. So now I'm within my data domain. I'm completely independent. How fast I do that, how I do it, what I want to do. And as the Datavault Builders, while we're modeling, implementing the stuff directly, we can start the data load and the data will be ready. What we need to do is now to create our data product. So we select what will be the grain of our data product. It will be the customer. Select more parameters. We can select if we want to have a as of now perspective or as of then perspective to output directly as well the full history about the customer. And now in here, we can select now the columns that are interesting for us. So even if we store more, if we create more history, let's take here maybe only the most important columns. And this here is created virtually in the database. So the data product is really accessible right now. So we're really finished. The only thing that we need to do is really, depending on your publish process that we want to deploy it. And this is how much time it takes to using a data vault if it's automated to map new data to your data model. And this was now a simple case. I just took the central model, extended it by a satellite, storing attributes about this element. In our second section, it will be a little bit more complicated. So let's start here the deployment as well. In that we have the order, and the order is not enough. We need to add here some more stuff, like the order line, which will be as well in the sales area. And then we can add the relation to the order. So we can extend the model without any issues, without being blocked by the other data domain team. And now when we extend our model, we can now look at the data, and I already as well pre-staged here the sales order detail and header line. We could look at the data, but I'm not doing that right now. I'm just adding here the order. And the ID here is the sales order ID. We can add here everything as well to the satellite, so this goes automatically as well. But we will now create a relation to the customer. How does this work out? We go and define the foreign key, which is linking to the customer. So yes, we are now between the data domains, but the relation to bring the data together needs to be defined by somebody, and it's usually the one on the many side pointing to something because they have the relation. So let's look here. If we have here the customer ID, and this will be the same as the business entity ID on the other side. So let's check that. It's not unique, that's fine. We have a many-to-one relation, so it will confirm us that customers have more than one order. At least some of the customers have. So that's perfectly fine. And we can add here now the relation. And that's it. So now we have loaded all our defined our data loads. And just to show you something different, in the background, automatically the jobs are created. So we can load all of this data completely automatic just by triggering the job that was created. And as well here, we need to create the interface for our data vault. So create our data product. Let's go in here. This will be at the grain of the order, as well as CD type 1 is good for a start. And in here, let's take maybe the order date. And what else could be interesting? The subtotal, and maybe if we have any total line here. And what we take in as well is the relation to the business key of the hub customer. And this will ensure that automatically then later on in Power BI will be able to define a model which integrates this data products from the different data domains. And as we imported these two elements, they have exactly the same naming. We don't need to configure anything. It will match out just like magic later on. So let's have a look at how does this look like. Looks fine. And let's publish that as well. And this concludes this part of creating a central model, distributing it to two different data domains, create local implementations. The last bit that we need to show is that now in the experience plane, we can bring together the data products and create one integrated report, which I will show you in the next section in Power BI. So what we need to bring now is all the data together in one place, and we can do this using data virtualization. If you have a platform like Snowflake, it's built in that you can create one database collecting already all the data virtually into one place, or you can use tools like Trino. Here I will directly do the integration in Power BI, just to give you one example that it really worked already out of the box. The data model works out of the box without any additional tools. As my two data domains are running now here on Postgres, just connect to the two instances. And we select now the customer information. We don't need to modify anything. Everything is named the right thing, so it will be added automatically here to the model. And here we can now select the order data. We don't need to here really do anything specific. By using the first model that already named the stuff the correct way, now we can profit by Power BI and any other tool specialized on building based on the right names, the data models like Click or Tableau can create a data model automatically. And this means that all the data is here. We don't need to do any manual coding. We don't need to modify any load scripts, but we can go directly and create our first report based on 2 different data products created by 2 different data teams and just see what the output will be. And the cool thing is that we can now use data from the above data products to create our first report. Let's put in here some kind of bar chart, and let's take maybe the year here from our order. Let's take the total as value, and now we can combine that with the person type from the customer. And let's maybe stack that. And now we see that some of our clients are individuals and some of them are blanks. And the reason is that we have loaded so far only really people, person data into our customer data product. So we need to extend it. There are as well businesses. That is probably explaining at least big parts of the remaining orders. But here already we see that automatically based on the data model that was retrieved from the different Datavault Builder instances, it was able to create a first report. So we have a first agile output. We see what the differences are and where we can go on and improve. And that's exactly the approach that we want to take here. I understand that everybody has a different experience and different approaches. It's just what I wanted to show in this demonstration is that it can make sense for certain companies to use the data mesh approach to put on responsibilities in local data teams if there's enough knowledge within these different teams. The second thing is disregarding if you decentralize or not, automation using a data vault approach can be very beneficial for you. And if you do it right, you can use the combination of automated data vault and the data mesh approach to completely automate your pipeline, distribute the responsibility for creating new data products into different data teams, and still at the consumption layer, you will have no additional work to bring the stuff together if the naming and metadata is matching between the different data domains. And this can be ensured by starting off by a central model, but the central model shouldn't be implemented in a way that is blocking the different data teams. So if you are interested, please contact me on LinkedIn so we can discuss further questions. I really recommend to read the book of Zhamak Dehghani. It has a very interesting concepts in there. I learned a lot, but still don't forget there's as well other literature about data management, data modeling around, which is still valid and which is always good to combine for your current situation. So my question would be, did anybody of you already implement a data mesh system? So let's start a short poll here. Let's see what your experience is. Okay, we have at least some people with experience. So my question would be for the people that already used Datavault before, data mesh before, does it make any sense what I try to explain here? Does our approach, what we recommend, make any sense to you? You can use the question and answer button, or you can use the chat button to write down your ideas or your opinions. So we have one question here, and the question is, how does the Datavault Builder work? And I left this a little bit out here to go too much details, but the idea is that we have a software which is delivered as Docker containers that's running on a server. We are using the web browser here, talking to a server, and the Datavault Builder tool talks always to a database. This means that behind this data model, there is one database. Behind this model that we created here for the data domain team is another database. And behind this data domain, there's even another database. So it's completely separated. And these databases can be of different types. They can be Snowflake databases. They can be Azure Synapse Analytics, SQL Server databases, Azure SQL databases, Oracle databases, Postgres databases, or Exasol. But we always work in real time with a database. And this allows us, in the second that we model something, directly to preview as well the result. This allows us, if we create interfaces, directly to check if they work. And this is our basic understanding of how agile development should work, that we don't create some definitions and we press the button later, but that in the second we do something, we see the results, and that we fail early if our assumption about the data is wrong, but that we can always verify it using the data profiling tool or with the support processes in the tool itself while creating the stuff. If you're more interested how the Datavault Builder works, which kind of process it supports, please feel free. You can go to our webpage. There is a requested demo that's completely free for you, and you can schedule a call for about 1.5 hours where we present everything, where you can ask your questions, and we can help you with understanding what the Datavault Builder tool is about. So if there are no more, so are there any practical examples? Yeah, thank you for the question. So practical examples that we have here is that, so as example, you can use that for different data domains, but we are using it, and that already for a longer time, for companies that have local branches, that we say sometimes that we have the central data model where we create and prepare something and we distribute it into different countries, and the different countries can create local implementations. But as well here, for this approach, it's really for bigger enterprises. If you have multinational companies or if you have banks that you can like define here maybe for money market, for precious metals and stuff like that, different data domains, and the local teams can implement their product-specific data modeling directly within the business unit where they are located, where they have all the business knowledge to implement all this stuff and still bring it together, because they're sharing always stuff like account, like securities and branches and whatever exists, which is shared between the different products. So it can be useful to have still a common model for understanding. Are there any similar tools in Azure? So the good thing is our tool is running in Azure. You can run it in a VM, you can run it on Kubernetes services on Azure. It's talking to Azure Synapse Analytics, to Azure SQL or managed instance, but I'm not aware of any other Microsoft tools that are having a similar approach of the model-driven definition of loads, if this is your question. But if you're in Azure, you can completely use that. We have even, if you have the option either to start up it yourself within your Azure tenant, or we have a partner that can take over the management and deliver you this as a service, that they run the tool within a resource group on Azure within your tenant. Yet, so thank you for all your interest. It was for me a very interesting session. I've seen the most people stayed until now, so I hope it created some interest. And I would be happy if you contact me on LinkedIn, if you book a demo on our webpage to go more into details and talk about your use case, how you could use the Datavault Builder automation and data mesh approach to achieve whatever your targets are. Thank you a lot.